This is vector review problem number 18. And in this problem, we have three vectors that we can see in the diagram. And I'm going through the words here that we've got two vectors that are acting upon this car, vector R2 and vector R1. Those are the two vectors that are forces that are pulling on the car. But as these two things are being pulled by these two ropes, the car itself is moving this pathway, this result, straight ahead. And we know one of the rope vectors. We know that it's 150 pounds, and we know its direction is down 15 degrees like this. And we have this the true course, the vector, the resultant vector, which is a magnitude of 200 pounds, and it's going in a 0 degree. What we don't know is the R2 vector. So thinking about that, I realize that the two ropes work together, rope 1 and rope 2. So I have the rope 1 plus rope 2 vectors are going to equal the resultant vector. And since I don't know R2, that's what I'm trying to solve for. So I will subtract the vector R sub 1 from both sides, and we'll end up with this equation. Well, if I take the resultant vector and I subtract R sub 1 vector, I will be able to tell you any information you need on this rope 2 vector. So we have that the resultant vector is 200, magnitude 200, with the angle of 0. Rope 1, we're going to subtract it. Now its magnitude is 150, so we're going to be subtracting the 150 times each of these. And remember, this angle, although it said 15 degrees, it's downward 15 degrees this way. So, it's clockwise, so that would be negative 15. Or you could put in the 300 and whatever degrees, but it's just, negative 15 degrees. So I put that in my calculator by distributing the 200 at cosine 0, subtracting 150 cosine of negative 15, and I get 55.111, and a bunch more decimals. I just rounded it there. And I do the 200 times sine of 0 minus 150 times sine of negative 15, and I have, so now I have the component form for that vector. I need to find its magnitude, and so we've got the formulas for magnitude. Square the A, square the B, add them together, take the square root, and you get 67.4. To find the angle, since both the A and the B are positive, I know this is in quadrant 1, so you simply take the arctangent of the B over the A, and when I do that, my calculator tells me that the angle is 35.2.